Question number 17. A. Figure 10 shows a ray of light traveling from glass to air. So we have this is the incident ray. This is the refracted ray in that direction. And the angle of incidence is 42. So the angle of refraction is 90 degrees. This is 90. So we say that when the refracted ray travel along the boundary of the two media, that is glass and air, then that is a critical angle. So it means since the incident ray is 42 and the ray is travels along the boundary of the two medium, that is air and glass, so it means 42 degrees is the critical angle. A critical angle. Part B, refractive index. Refractive index, if we take this is our 42 is our angle C, we say that sine C is equals to 1 over n, implying n is equals to 1 over sine C, which is equals to 1 over 42 degrees, and this will be able to get 1.4, and this is 1.494. Alternatively, you can say that is refractive index. You can say n is equals to the sine of the refraction angle, that is 90 degrees, divided by the sine of incidence, which is 42 degrees, and you can use your calculator. You'll be able to get 1.494. So that is how you work out that part of the question. So let's go to the next step. Question number 17b. A piece of metal is embedded at the center of an ice block 15 centimeters from the surface of the ice. Given that the refractive index of ice is 1.32, determine how far from the surface of the ice block the metal appears to be. So we say to calculate the refractive index, it is equals to, we say it is real length divided by apparent length. This is R, apparent length. And what do we have? So because we are required to find the how far from the surface of the metal of the ice block the metal appears to be. So this is apparent. We say it is apparent length. So which is equals to, now we will take now this is we will interchange. So we have this is equals to real length. You divide by refractive index, which we have the real length is 15 and the refractive index we have been given, it is 1.32. So you can use your calculator and you find that this will give you 11.36 centimeter. So that is the length, or that is how far the metal block appears to be from the surface of the ice block. So that's how you work out that. Part C of question number 17, figure 11 shows two rays of incident on a diverging length. So we have this is the symbol that is used to represent diverging lengths. So these are the two rays. So we are told complete the ray diagram to show the path of rays after passing through the lens. So you realize that this ray, if it extended, it will pass through the focal point. Let me show you that. So it will appear like passing through the focal point, and it will be refracted through the lens parallel to the principal axis. So let's see how it appears. Now that will be the direction of the ray after it is refracted. Then we have the other ray which passes through the optical center of the lens, and once a ray passes through the optical center, it continues uninterrupted. So there is no refraction of that ray, and we can be able to show that. So we can be able to show how it look like using a ruler. You can extend like that, and now this will be the direction of that ray. So that is what will be the complete rays, and you can see the two rays are parallel, so it means that they will not meet, they will not form an image, because an image is formed when the two rays meet. So that is how you should approach that question. So part D of question number 17, we are Roman number 1. State two differences between the human eye and a camera. So to make it easier, we can say this is the eye and this is the camera. The first, because I want to put several of them, but you are required to put two. So you can say the eye has a variable focal length, but the camera, you can say that is one. Camera is a focal length is fixed. So that's one difference. We come to the second one. We say that image distance, that is image distance from the lens, is almost constant. Image distance from lens, that is let's say lens, almost constant. And here we can say image length variable from the lens. So that's another difference. The other is this is view multiple images. That is images, but the camera only take one photograph. And another difference is that eye has a, that is lens is muscular. This is lens is muscular, but in this case lens is made up of glass or clear plastic lens. So you can choose among these four and you'll be able to get 2 marks. So you only need 2, but it is important that you know even the others, so that in case you forget one, you can be able to answer with another one. So state the name of the part of the eye that enable the lens to focus images of object at different distances. So this is called subsidiary muscles. And subsidiary muscle is a ring of smooth muscle in the eye middle layer, which is also known as vascular layer, that controls the accommodation for viewing object at various varying distances. So that's how you answer that part of the question. So that's question number 17. Let's go to question number 18.